In this lesson, I'll cover HSRP, short for Hot Standby Router Protocol, but we'll also touch upon other first hop redundancy protocols. First hop redundancy protocols are a family of protocols that all have the same goal: to provide redundancy or ensure availability of a default gateway. As we already know, a gateway router is the router sitting between an internal network and an external network, usually the internet. Another common thing with gateways is that if we have only one gateway, which is what we had in our previous exercises, then that one gateway is a single point of failure. The idea behind these protocols is to allow two or more routers to act as gateways, and usually it's in standby and active modes. In short, one router assumes that he's the gateway and therefore that router is active, and the other one is standby. And the standby router's job is to pretty much wait for the active router to fail so that he can take over. I also mentioned here that these protocols are not the same as VSS VPC because my students usually asked that. If you're not familiar with it, VSS, short for Virtual Switching System, is also some kind of redundancy, but completely different. It kind of stacks several physical switches into one virtual device with the goal of increasing efficiency, bandwidth, and etc. And those are usually used in a network core, where FHRP protocols are used on gateways, which are naturally placed at network edge. Now let's quickly go over several first hop redundancy protocols. We will be working with HSRP, which is Cisco proprietary, but if you're not working with Cisco equipment, you can use VRRP, which is an open standard and is short for Virtual Router Redundancy Protocol. And then there is one protocol that is slightly different from HSRP, but is also Cisco proprietary, GLBP, which stands for Gateway Load Balancing Protocol. And as you can guess from the name, it also allows for load balancing. HSRP, which we will work with, only offers a mechanism to automatically detect failure on one gateway and reroute the traffic to the other gateway so that the communication can continue. But GLBP can balance traffic between the two routers, and then if one fails, you still have one working gateway, or however many gateways you stack up into GLBP. Now a few details on HSRP. I already mentioned that it's Cisco proprietary, but let me explain how it works. We're looking at these two routers up here. Imagine that they're connected to the internet up north. Only one of these routers can be the gateway to these computers down here. What we can do with HSRP is we can use the same IP address on both routers so that if one of them fails and the other one takes over, the end computers have no idea that anything changed. They are still using this 10.0.0.1 IP address. These two routers will each have some other IP, let's say 10.0.0.5 and 10.0.0.6 on these interfaces connecting to the switches. But when assuming their HSRP gateway role, they will use this 10.0.0.1 IP address. Now, the roles I mentioned are active and standby. Router with the highest priority will be active, and the one with lower priority will be standby. Let's talk about configuring HSRP, and things will clear up significantly. First of all, You should know that HSRP is configured in the interface configuration mode. There is no special HSRP configuration mode. You configure HSRP on interfaces that are actual gateways to the end devices in a given subnet. There are some details here. The most important one is, I'm talking about these details right here. The most important one is this default priority number, and that is 100, but we'll talk about that some more in the coming slides. This command sets up that one virtual IP that the active gateway will use. Of course, this router, router 1, already has an IP address configured on this interface. But now with this command, we are setting up HSRP. So we will configure some other IP from the same subnet on this interface. Let's call it physical interface IP. And then in HSRP, we will configure this virtual address. The router will use the real IP, the one configured directly on the interface, until it becomes the active HSRP router. Of course, endpoint users will only know this virtual IP address. They will always use that one IP address, not even being aware of the real IP configured on this interface. By the way, this number 1, as it says here, is the instance number, the HSRP instance number. This tells you that there can be multiple HSRP instances on a single router. Actually, you can have up to 32 instances or groups. Sometimes it's called groups as well. In our next exercise, we will create 2 instances. So not in this exercise, we will only have one group in this exercise, but in the next lessons exercise, we will have 2 instances because we will have 2 VLANs. So you'll see how and why those are used. As for priority, priority is, as we already mentioned, by default 100. And a higher number means higher priority. The router with a higher priority will become the active gateway, which means that the traffic will go through that gateway. And the router with the lower priority will be a standby gateway. This is the command standby 1. This is still that group number we're using. And then word priority, and then we say the number. Now, in case the interface we're configuring with HSRP fails, or another interface that is being tracked, I'll touch up on this later. So if another interface that we're tracking fails, this number, this priority that we manually configured, will be reduced by 10. Therefore, making this router's priority 95. So if the other router, the router that is currently standby, so let's say that this router is active and the other redundant router is standby, in that case, if this router's priority drops to 95 and the other router's priority is default 100, then that other router's priority will be higher than this one's because it will become 95, and then that other router will become the active router. I mentioned tracking in the previous slide, and here I'll explain what that really means. First of all, HSRP will of course track the interface you're configuring it on, so this interface. It will also react if the router itself suddenly dies, but if you want it to react to anything other than that, you'll have to specify it. This is the command that tells HSRP that it should track this interface, which means that if this interface fails, This router will immediately reduce its priority by 10. Now, in order for these changes between active and standby to happen immediately and seamlessly, we should use this preempt command. You should note that if you add a new router to the network, it will also immediately take over the active role if its priority is higher than those other routers that already existed in the network with lower priorities. And that's it for the explanation part. Let's go to the exercise.